Good morning, everyone. Happy Tuesday. I hope your day is going well so far. Now, before we get into things, just a reminder that we are in week 5, in case you didn't know. So excellent job on working hard up to this point. Give yourself a pat on the back at this moment. Keep up the great work. I know there's many challenges that can be faced while working online at home, but just know that I'm here for you and you're doing what you need to do. You're doing well, so keep it up. Now, before we get into today's work and going over operations in algebraic thinking and numbers in base 10, which is what you worked on specifically today, I want to give a few reminders. So Imagine Math, make sure you get your 3 past Imagine Math lessons done, doing your best to get those done, okay? Practicing multiplication division facts. I want you to continue with that. There are resources on my teacher page on your Clever account. You know this, okay? Make sure you're practicing your multiplication division facts in some kind of way, okay? This week, we're going to continue with 3rd grade review. Next week, we're going to step up to 4th grade material. On Friday, I'm going to give you a video specifically on instructions and details on what that's going to look like moving forward for our online class. But that's going to happen next week, and I'm going to give you a video on Friday about that. So we're not going to worry about that right now. We are continuing with 3rd grade material this week. Today, you're working on your 2 pages that you had. Tomorrow, you're going to have another 2 pages that look similar to what's today's. Thursday, I hope to see you on Zoom for Math Kahoot. You received instructions on Edmodo from me, and then I've also emailed your parents. So if you're hoping to attend, I hope you've read the instructions on what to do, on how to attend, okay? You don't have to go. It's completely optional, but I would love for you to come, okay? Friday, once again, you're going to take your, or not once again, you're going to take your multiplication division quiz, and then once again, which is what I was about to say, you're going to watch that video that I'm going to give you talking about next week's material on 4th grade material, okay? Now, before we get into things, I'm going to play a number rock video multiplying by 6 and skip counting by 6, and then we'll get started, okay?
6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72. All these are multiples in the 6 table. All these are multiples in the 6 table. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72. All these are multiples 6, 12, 18, 24 in the 6 table. 30, 36, 42. All these are multiples 48, 54, 60, in the 6 table. 66, 72. 24, 30, 36, 42, 48, 54, 60, 66, 72. All these are multiples in the 6 table. All these are multiples in the 6 table.
All right, I hope you enjoyed that video. Now let's get started. All right, so this is what you should have in front of you. Now this, working on operations in algebraic thinking and number base 10, 3rd grade review. Now, the directions for this says, show all strategies when solving the problems. It says, use notebook paper if needed. Once again, if needed. You can always just write in here, just like I'm about to do. Okay, so let's go over the first one. It says, show on the number line 15 divided by 3 equals, write the quotient, and then quotient we know is the key word for the answer to a division problem. We know that is the definition, excuse me, not keyword, definition of what a quotient is, which is the answer to a division problem. 15 divided by 3 equals 5. But how do we show that on a number line? Remember, when you're showing it on a number line, it's a little different from multiplication. Multiplication, you would be going up. Division, you're going back down. You're going back towards that 0. As you can see, I wrote a 0 so you can get a visual of how this is going to look, okay? So if we have 15 divided by 3, 15 is going to be our starting point. So we're going to start at 15, okay? 3, okay? 3 is how many times we're going to skip count down to 0, okay? So if we take a look here, I've highlighted 15. That means we're not going to include 15, but we are going to skip count down by 3s, going all the way to 0. And however many spaces that we skip, however many times that we have to do that, that's what our answer would be. In this case, it would be 5, okay? And I went ahead and drew a visual for you here. So when we went down by 3s, we went to 12, then to 9, then to 6, then to 3, and then you go down to 0 because that's what you're trying to do when you get to division. 15 divided by 3 equals 5, okay? Next one, it says rewrite the addition problem as a multiplication equation, okay? First things first, if I see the same number being repeated in addition, we know that that is repeated addition, okay? Now, the way we figure out what this multiplication equation would be is we're going to count all those 3s, okay? And when we do, that's going to tell us what our multiplication is by that number that we see in the repeated addition. In this case, it would be 3 times 9, okay? Because we have 9 of the 3s, 3 times 9 equals 27, okay? So this is the same thing as this. This is repeated addition, whereas this is multiplication. In this case, they asked us to write the multiplication equation, okay? Taking a look at the next box, it says write the multiplication equation. Now, when we're looking at this, we are multiplying by however many groups we have, as well as how many things are inside the groups, okay? So in this case, we have 1, 2, 3, 4, 5, 6. We have 6 hearts in this group. Now, in this case, if I know there's 6 hearts in this group and it's telling me to write a multiplication equation, I know that there's probably going to be 6 hearts in all the rest of the groups, okay? So 6 might be our starting number, might be. You can always flip it, okay? Then we count how many groups we have, of course. 1, 2, 3, 4. So we have 6 times 4 equals 24. That's our multiplication equation, okay? Next box, it says write the division equation. Now, this is a little different. What we do here is we are going to count all of our little hexagons here, and then we are going to divide it by the number of groups that we have. So taking a look, we have 27 total of these, okay? If you count, we have 27 total. Here's a strategy you can use. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? 9 times 3, you have 9 of these in each of the groups. You have 3 groups. 9 times 3 equals 27, okay? And that's how you do that. I'm sure you're breezing right through this. Next box, it says, and if 5 times 6 equals 30, then 5 times 60 equals, okay? Well, first things first, this should be, you should be using logic to answer this question, but for those that need more of a breakdown, I'm gonna break it down for you, okay? If 5 times 6 equals 30, we know that, then 5 times 60 equals what, okay? All you need to do is add another 0 because you're working with a multiple of 10, okay? So 5 times 6 we know equals 30. Bring down that 1 that you see, you have 300. So you would have 300 as your answer for 5 times 60. All you do is add that 0 that you see. That one should have been more of a logic question and quickly answered. But if you didn't, I broke it down for you, okay? Next question, it says, there were 4 people in line waiting for movie tickets. If each of the tickets cost $2, how much money would be spent, okay? I'm gonna highlight a few things here. Okay, so we have, my highlighter's pretty good. It's all right. Okay, we have 4 people in line, and then we have tickets that cost $2. It says how much money would be spent, would be spent, okay? So in this case, all we're going to do is multiply 4 people times the $2 fee, and that will give us $8, okay? As to how much would be spent, would be. We're not sure if it's gonna be, but we know it would be, okay? Next box, it says how many groups of 4 can you make with the 24 shapes below? Okay, so taking a look, it says how many groups of 4. So what I did is I went ahead and circled literally groups of 4. So 4 in a group, and I kept going until I circled every single one of them in a group, okay? And when I did that, you'll notice I have 1, 2, 3, 4, 5, 6 groups. We know that 6 times 4 equals 24, okay? Now, here it says circle groups, write division problem. All we need to do is just flip it. So 24 divided by 4, what we're given in our word problem, equals 6. And that's it, okay? Next box, write the multiplication equation from the array. Okay, so when we take a look at our array here, remember we multiply the column times the row. Okay, so in this case, you could have done 3 times 1, 2, 3, 4, 5 times 5 equals 15. We know that. Or you could have flipped it and done 5 times 3. They both equal the same thing, which is 15. Okay. Last question. It says, which shows the associative property? Before we do this, let's go back to what the definition of associative property is. Okay. All right, so when we're taking a look at the associative property, it says numbers can be grouped differently and the answers will still be the same. So our example here, we have 3 plus 4 plus 2 equals 9. And then all they did was rearrange the groups differently, the numbers differently in a group. Okay, so they did 3 plus 4 together instead of doing 4 plus 2 together. So 3 plus 4 together, and then they added 2, and it still got them 9. So once again, associative property is numbers can be grouped differently and the answers will still be the same. Okay. Now let's go back to our problem. All right, so which shows the associative property? When we take a look at that first one, we have 7 times 6 times 9 equals 7 times 6 times 9. Notice those same 3 numbers are being used over again, and they're just grouped differently. So we know that A is definitely representing the associative property, okay? All right, we're gonna move to the next page. So go ahead and get ready for that next page that you had to do. All right, now we're working in numbers in base 10, which is all of that rounding and that addition and subtraction. In this case, I don't believe we have subtraction for today, but we do have that rounding that we're starting with here, okay? So taking a look, it says round to the nearest 10. If I have 59, remember, 5 or more, raise the score, 4 or less, let it rest. Okay, so in this case, when we're rounding 59 to the nearest 10, that means we're gonna take a look at our tens place, but we're gonna circle our ones place, and our ones place is gonna tell us whether to go up or go down. We have 9, that's greater than 5, so we're gonna round that to 60 for our nearest 10, okay? Next number, 238. Although it's 238, you're still rounding to the nearest 10, okay? So what you're gonna do is you're gonna take a look at your tens place, circle your ones. Your ones is gonna tell you whether you're gonna go up or go down. 5 or more, you're gonna raise the score. So when I round to the nearest 10 to 238, I'm gonna round to 240, okay? Next number, okay? Round to the nearest 100, okay? Now we're rounding to the nearest 100. We've moved away from rounding to the nearest 10. We're now in that rounding to the nearest 100, okay? So if I have 429 and I'm rounding to the nearest 100, that means I'm gonna find my hundredths place and circle my tens. Now my tens is gonna tell me whether I'm gonna go up or go down. And remember, 5 or more, raise the score, 4 or less, let it rest. Okay, so 2 is much less than 5. So that's that 4 or less, let it rest rule. So we're gonna let it rest to 400. I'm rounding to the nearest 100. Next number, although we're given 1,249, we're still gonna follow those directions of rounding to the nearest 100. Okay, so we're gonna find our hundredths place, and then we're gonna circle our tens. And our tens is gonna tell us whether we go up or go down. In this case, 4 or less, we let it rest. So we're gonna let it rest down to 1,200, okay? Rounding to the nearest hundred still, okay? Now we're gonna move on to some addition, which I'm sure you're like, this page was so easy, Mr. B. And I love to hear that because we've come a long way for you to be able to be that confident. Absolutely, I love it. Okay, so let's get started with our addition here. All right, very simple. So we have 9 plus 5 that equal, remember we start on the right side, then work our way to the left. If we need to regroup, we regroup, okay? So 9 plus 5 equals 14, put down my 4, carry my 1. 1 plus 5 equals 6, 6 plus 2 equals 8. My answer should have been 84, okay? Next question, we have 9 plus 5, put down your 4, carry your 1. 1 plus 8 equals 9, 9 plus 0 equals 9. 1 plus 2 equals 3, 394, okay? 9 plus 0, last problem, here we are. 9 plus 0 equals 9. 5 plus 6, we know equals 11. Put down my 1, carry the other 1. 1 plus 4 equals 5. And we carry down that 5, and it's 519, okay? All right, let's see. All right, let's see. We have a word problem, so I have my highlighter nice and ready. Okay, so it says George's school was collecting cans for recycling. They had 81 bags, okay? 81 bags with 67 cans, okay? Inside each bag, that keyword each. Which expression shows about how many cans they collected, okay? So we're working with 81 bags with 67 cans inside each bag. And then it says which expression shows about how many cans they collected. That means we're going to make an estimate here. So 81 would be about 80. We know that. 67 would be about 70. So looking at our options, we're going to look for what that represents when we're trying to make an estimate about how many cans they collected. That would be C, 80 times 70. Okay. All right. So well done if you got that answer. Now let's move to the next one. Ooh, trying to fix it for you. See, nice. Okay, there we go. A farmer was planting vegetables in a garden. He planted 623 corn seeds. Okay. The reason that I highlighted 623 corn seeds was because we also always get that total number at the very beginning. Sometimes it's an additional number, but most of the time it's our total number. But let's keep reading because we never know. Okay, this is 519 turnip seeds and 831 potato seeds. So now we know that that was just an additional number. We know that's a part of something that we're going to have to do with the other numbers. So we're either going to have to add with all of these numbers, subtract with all these numbers, maybe multiply, maybe divide. All right, let's keep reading. It says, how many seeds did he plant total? Our keyword total tells us that we're going to add. Okay, so we're going to add 623 plus 519 plus 831. But what we're going to do is we're going to take it one step at a time, as I always tell you. So 2 numbers at a time will work just fine instead of adding all 3 of those at the same time. Okay, so let's do 623 plus 519. Okay, we know that 3 plus 9 equals 12. We put down our 2, we carry the 1. 1 plus 2 equals 3. 3 plus 1 equals 4. Okay, 6 plus 5 we know equals 11. Do I just leave it like this? 1142? No, I need to put my comma. 1,142. Now we have our number. But we're not done yet because we still need to add 831 potato seeds. Okay, so we're going to do that. 831. 2 plus 1 equals 3. 4 plus 3 equals 7. 1 plus 8 equals 9. And then we carry down our 1 as well as our comma, and we get 1,973. Okay? Right now we're moving on. Here we're going to be expected to write word form of 432, our number here. Let me highlight that for you so you can see that better. Not sure if you can see that as well. Okay, 432, your total number. So we're going to write the word form here, but then we're going to write the expanded notation form. Some of you may be wondering, what is this? I promise you know exactly what it is, as you can already probably tell from the plus signs. And then you also have the place value form. Okay, so let's start from the top. When we think about 432, we say it aloud and we write it exactly how it sounds. 432. 432. Okay? Now our expanded notation form, all we're going to do is just break it apart. So 400 plus 30 plus 2. Okay? Just breaking that apart in expanded notation form, breaking that total number 432 apart into hundreds, tens, and ones. Place value form is the exact same things, but instead of writing the numbers 400, 30, and 2, you're just going to write how many hundreds there are, how many tens there are, how many ones there are. So we have 4 of the hundreds, only 4 hundreds, and then we have 3 of the tens, 3 of the tens, because remember, if it's tens, 10, 20, 30, so we don't need to write 30 of the tens. That wouldn't be correct. It would be 3 of the tens, excuse me. And then ones, we only have 2 of the ones. Okay. All right, and that concludes our work for today. I'm going to play a FlowCab video for you, and you'll be on your way.
Check it out. Yeah. If 7 guys walked
down the street and picked up trash, 9 pieces each, how much trash would be up off the street? That's 7 times 9, and that's 63. Cause
if 7 kids wanted to have fun and bought 3 toys for each and every one, how many toys would that be? A ton? Well, 7 times 3 is 21. Cause
7 times 1 is 7. 7 times 2 is 14. Right. 7 times 3 is 21. It's like I'm crouched down and I'm ready to run. Because
7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. I know all the 7 facts. Do you?
7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. And 7 times 10 is 70. Here we go.
Isn't there a name for the numbers on these tables? Like 14, 21, and all the rest? Those numbers are multiples of 7, you bet. So when you multiply 7, that's what you get.
Here we go. 7 times 6 is 42. 7 times 3 is 21. 7 times 5 is 35. 7 times 9 is 63. 7 times 2 is 14. 7 times 10 is 70. 7 times 1 is 7. 7 times 8 is 56. 7 times 4 is 28. 7 times 7 is 49.